Let's talk about rules of exponents. So I'm hoping that much of this section will be a review from Math 60, but it might not be, so we'll go over it like it's brand new material. So first, let's just define what an exponent is. Exponents are repeated multiplication. So anytime we see an exponent, it just means that we're repeatedly multiplying. Repeated multiplication. So, for example, b to the nth power is b times b times b times b n times, assuming that n's a whole number. And later on in Math 65, we're going to learn what happens when n is not a whole number, but for now it just means multiply b times itself n times. So that makes b to the n an exponential expression. B is the base and n is the exponent. So let's try some, make sure we understand this. So 5 squared, by that definition, just means 5 times itself 2 times. So that would be 25. That makes 0 squared, 0 times itself 2 times, which is this 0. Now here's where people sometimes make mistakes. So there's a big difference between parentheses and no parentheses. Parentheses means that it's a negative and a 3 being squared. So this would be negative 3 times negative 3, which is positive 9. However, if there's not a parenthesis, then order of operations says to treat this like a negative 1 times a 3 squared, so that the negative and the 3 are separate pieces because there's no parentheses. So that would just make it a negative and then a 3 times a 3, or negative 9. So order of operations, PEMDAS, says do the exponent before you worry about the multiplication by the negative. So we get a negative answer for negative 3 squared. All right, let's try cubing. 2 cubed would be 2 times 2 times 2. We multiply these and get 4 times 2, which is 8. This is really something that for this class, it's gonna be useful to memorize. All the single digits squared and even cubed, the more we have memorized, the easier that is. So 2 cubed, 8 shouldn't be a difficult one. We shouldn't have to write it out every time like this. Well, then negative 2 cubed would be negative 2 times negative 2 times negative 2. And I'm going to do it the same way this first time. So negative 2 times negative 2 is positive 4. But a positive 4 times a negative 2 makes a negative 8. Notice because there was parentheses, I included the negative in the cubing. If there weren't parentheses, like if it were just negative 2 cubed, that would be a negative 1 times 2 times 2 times 2. In this case, that also gives negative 8, but it's different. I know it ends up being the same, but I need us to understand that difference between parentheses means the negative is part of the cubing. No parentheses means we cube first, and then at the end multiply by a negative 1. Let's see what happens when 0 is in our exponent. We saw here what happens when 0 is in our base. So if 0 is in our base, 0 to any power is 0, as long as the exponent's not 0, because then that's a whole nother sort of messed up contradiction. But 0 to any whole number power is 0. But when 0 is the exponent, it actually ends up being 1. A lot of people do not believe me with this one, so I usually pull out the calculator, because somehow y'all are more likely to believe the calculator than me. So let's try this first example on the calculator. 6 to the 0 power. So on the calculators that I have, this is the button for exponent. You might also see a button that looks like a caret. So on some calculators and even on a computer, you might see that little symbol that also means exponent. But here it's this y to the x power. And then I enter 0 equals, and look, it's 1. This rule really does work, that any base to the 0 power equals 1. So it doesn't matter what x is. X to the 0 power, that's going to equal 1. 10y to the 0 power, that equals 1. But let's talk about what happens if there's no parentheses here. 10y to the 0, like that. because with parentheses, anything to the 0 power is 1, but without, this is the same as 10 times y to the 0, or 10 times 1, which is 10. So we really got to pay attention to parentheses when we're dealing with exponents, or really when we're dealing with anything in algebra. Parentheses change the order of operations. Let's try -1, no, not -1. That's too boring because the answer is going to have something to do with 1. Let's just do -2 to the 0 power. I didn't use parentheses, so this would be a -1 times 2 to the 0, which is -1 times 1, or -1. If it were in parentheses, it doesn't matter what number or expression we have. If it's all in the parentheses to the 0 power, then it equals +1. But without parentheses, we gotta be really careful about order of operations, that the exponent is only applied to what's right before it, and then anything else that's in front gets multiplied. All right, so it's easy as long as we remember our order of operations, that a 0 exponent makes 1. Let's work with some other exponent rules. This one is called quotients to powers rule. Quotient just means division. So it's what to do if we have a division or a fraction raised to an exponent. And what this says is that we can square or cube or whatever exponent that is, do the top and the bottom separately. So a divided by b to the nth power is the same as a to the nth power divided by b to the nth power. So let's see what this looks like. So this first one, instead of viewing it as 5, 6 squared, which we could, right? That would just be 5, 6 times 5, 6, and then we could figure that out. But what this is saying is that we have another way to do it. So the other way to do it is just to view it as 5 squared over 6 squared, which is 25 out of 36. So then even if we weren't great with fractions, we could get there probably quicker. But it's the same thing, right? To multiply these fractions, we'd take 5 times 5 and get 25. We'd take 6 times 6, get 36. But this says we can just square the top and the bottom. When this is even more important is when we have variables, so we can't just type it into a calculator. We have to know that this cubed, now I like showing both ways. So one way to do this is to write it out. Cubing means multiply it 3 times by itself. But the rule that we're using says you could also just do x cubed and then 2y cubed. I use parentheses in the bottom because we haven't talked about this yet, but even here it's hopefully clear that we need to multiply the 2 times 2 times 2. So this needs to be that the 2 is cubed and the y is cubed. It's not just one or the other. So our final answer for this is x cubed over 8 y cubed. It's a really common mistake to forget to cube the 2, but it's a separate piece of this equation than the y. So we need to make sure to cube every piece of that fraction. When we do not do that, as soon as I make a rule, right, we got an exception. The exception is with addition and subtraction. We cannot distribute exponents over addition subtraction. So let me put that up here. Note that exponents distribute over multiplication and division. Like what we saw here, we had multiplication, we had division. The exponents just go to each piece over multiplication, division. But not addition, subtraction. So if the bottom of this fraction down here were like 2 plus y cubed, that does not simplify. There's no other way to write that. I mean, I guess we could multiply it out, but that would be really messy and it's not simpler. I don't know, I put an extra if in my simplify. But we need to be careful with When there's multiplication, sure, we can just do 2 cubed, y cubed. If there's addition or subtraction, you cannot just do 2 cubed, y cubed. It doesn't work with that. But what we can do when there's addition or subtraction is look for like terms. So like terms mean we have the same variables raised to the same exponents. And that's when we can simplify addition and subtraction. So in these three examples, the first one, we have 3x to the 9th plus 6x to the 9th. The variables are both x, and the exponents are both 9. Exponents 9, so these are like terms. The coefficients, the numbers out front, are not what I'm considering. I'm just looking at same variables, same exponents. So that means together, this equals 9x to the 9th. After we verify that they're like terms, we just add the coefficients. So 3x to the 9th plus 6x to the 9th makes 9x to the 9th. Let's try another one. So here, my variables are both y. The exponents are both 2. So these are like terms. Like terms, check. So once they are, now we just need to do 5 minus 2. 5 minus 2 is 3. And then we keep the same variable, same exponent. So 5y squareds minus 2y squareds is the same as 3y squareds. Last example, 9x cubed plus 2x squared. These are not like terms, which means that it does not simplify. Addition and subtraction is very particular. We cannot add or subtract unless the pieces are exactly alike, meaning same variables and same exponents. The numbers out front don't have to be the same, but the base and the exponent do in order to add or subtract.